These notes are the sum and difference identities with triangles, part 2, finishing up these examples, examples 2 and 3 on the back of the notes. And what we're going to do, once again, today, is we're going to determine the quadrant that each function is in. We're going to find any missing side lengths. We're going to determine which formula to use, which I like to do firstly, but it doesn't matter. I'll try to follow the directions today. Then we're going to take our values and put them into the formula, replacing the words completely. And finally, we're going to simplify and make sure to rationalize the denominator if possible. So I'm going to flip back for a couple of minutes and just remind us of this picture here with the positive quadrantal angles and the negative quadrantal angles, because looking back at that can be helpful to determine what quadrant our different functions are in. So we're given the cosecant value on this particular, we're going to find tangent of x plus y, given the fact that cosecant of x equals negative 5/3. And really, even before we start, let's convert cosecant to the fact that it could be sine, which we're more familiar with. Cosecant and sine are reciprocal functions, so this is going to be negative 3/5. We flipped the fraction, and that may be helpful for us. Now we're going to determine what quadrant we're working in. Well, it says pi. Pi is over here to the far left, and 3 pi over 2. And consequently, what we see when we label that triangle, if we even needed to, is that we're going to draw our triangle here. Notice, once again, that our angle is going to be touching the origin. When we go to the left on here, it's going to be a negative value. And when we go downward, it's also going to be a negative value. A little bit hard for me to squeeze in. The hypotenuse, which is across from the box in there, is always positive. And we talked about that in our last set of notes, but just want to remind us of that fact. And now that we rewrote this function in terms of sine, as I finish here labeling this triangle, across from the x is the opposite, which means that our value along the x-axis is going to be the adjacent. And now we can fill this in. Sine is the opposite divided by the hypotenuse. So opposite is going to be the negative 3. The hypotenuse is going to be the 5. And we need to find the other side. And once again, for a few of you, either in the classroom or on the video, you already know what that other side is. If you write down that the other side's 4, I'm fine with that. It's a special right triangle. It's a very popular triangle. But if you don't know that, I'm going to say a squared plus negative 3 squared is 5 squared. To find the value, if you don't recognize that fact, and we get a squared plus 9 equals 25. Negative 3 times negative 3 is positive 9. Subtract 9 from both sides. We get a squared equals 16. And the inverse operation of squaring, square rooting, we get a equals 4. We only want to deal with the positive value because we are dealing with a distance, a length of a triangle. And now we know all 4, even though we can't see them very well. We went to the left 4, which is why it's negative 4. We went down 3, which is why it's negative 3. And our hypotenuse is 5. When we look at our second value here, we've got cosine of y equals 5/13. And what this one says is it says negative pi over 2 to 0. Well, once again, the negative tells us the direction, but here's negative pi over 2. Here's 0. And you can look back on your second page of the notes and see that between negative pi over 2 and 0 is going to be in the fourth quadrant. And we draw our triangle. And this is not B. It's going to be Y, angle Y. And before I get going too far here, I'm going to switch colors and label this. Across from the right angle is the hypotenuse. Across from Y is the opposite, which means that our adjacent is along the x-axis. We're given cosine. And cosine is defined as the adjacent divided by the hypotenuse. So our adjacent length is 5 and the hypotenuse is 13. We need to find our opposite length. And by the way, when we do, it's going to be negative because we're going in the downward direction. And once again, there may be a few of you who are familiar with this particular special right triangle as well. Pythagorean triple. And this is 5 squared plus b squared equals 13 squared if you don't know it ahead of time. So 25 plus b squared equals 169. Subtract 25 from both sides. And we get b squared equals 144. And then when we finish, by taking the square root of both sides, we get b equals 12. A pretty popular Pythagorean triple. And we fill that value back in again because we're going downward in this triangle. That's why it's negative 12 for that length. So far we've determined the quadrant that both are in. We've found any missing side lengths. Now it says determine the formula that we're going to use. Well, this problem is asking us to find tangent of x plus y. So looking at the top of our paper, we see that this is going to be the tangent of x plus the tangent of y. We had the plus, which is on top in our identity, listed identity. So we have to go to the top sign, which in the numerator, the top of the fraction, is also a plus. And then we're going to divide by 1 minus, that's the value that's on top, and that's going to be tangent of x times tangent of y. So there's the formula that we need to use. So let's go back and look at over here in our blue triangle. Well, what we need is we need to know, well, what's tangent of x? I like to list them. Tangent of x is going to be the opposite, which is negative 3, divided by the adjacent is negative 4. And negative 3 divided by negative 4 is 3/4. Same thing over here for our green triangle. We need to know what the tangent of y is. And the tangent is still the opposite divided by the adjacent. So tangent of y is negative 12 divided by 5. No radicals even in this problem. So we're going to be able to use our calculators and everything, which is a huge relief to some. When we fill this in, it's going to be 3/4 plus negative 12/5 divided by 1 minus 3/4 times negative 12/5. if you have a fraction button, you can type that whole thing in here. Unfortunately, not everybody in this room has a fraction button, so I'm going to kind of sort of do it without. I'm going to simplify the numerator, the top of the fraction, simplify the denominator, and then I'm going to divide. For those of you who don't have a fraction button, when we type this in, it's going to be 3 divided by 4. Again, use a fraction button if you have it. 3 divided by 4 plus negative 12 divided by 5. It gives us that decimal there, and we don't want decimals for an answer. But once again, on my calculator, it's going to write it as a fraction. On yours, who don't have a fraction button, it'll write it as something like negative 12 divided by 5, like that. But you go to Math, Enter, Enter. And it gives us that value here of negative 33 over 20. That's the value in the top. Negative 33 over 20. And we're going to divide by, here now it's going to be 1 minus 3/4 times negative 12/5. Again, if you have a fraction button, you could have typed the entire value in. But if you don't have the fraction button, then we have 1 minus, and then I'm going to put 2 parentheses. I'm not sure if we need 2 or not, but 1 minus 3 divided by 4. And I need a second parenthesis, so I'm going to go back here. And maybe we're going to find out if it works. Times negative 12/5. I'm not sure if that works here. And it did. So Math, Enter, Enter. There's our fraction button now. So in the bottom, we ended up with 14/5. And then lastly, what we can do is we can divide. So again, on a calculator that doesn't have a fraction button, you have to type in the negative 33 divided by 20, then divided by 14 divided by 5. And you could probably use the decimals there. But lastly, Math, Enter, Enter, and we get our fraction value of negative 33/56. For those of you who have the fraction button, it's worth it. But negative 33/56. That's our exact answer on this problem. So we've done a sine, we've done a tangent. Let's finish with doing a cosine. The practice is on the back of this set of notes. So if you're ready to start doing the practice, it's back there. And we need to find the exact value of cosine of alpha minus beta. Those are the Greek letters, but they look close enough to the A minus B that I think they're understandable for you. And what we're going to do is we're going to draw our triangles, and we need to put them in the right quadrants. And on our first one, sine of alpha is the square root of 5 over 3, and we're going to be between pi over 2 and pi. Go back over here, pi over 2, and pi. So that means we're going to draw our triangle in quadrant number 2. Label if you need to. We're dealing with alpha. I'm just going to put an A there. And our hypotenuse. It's here. Across from A is our opposite, and I'm not sure if I can write that in. It's not going to let me. But I can write in my adjacent. Here. And what we know is sine is opposite divided by hypotenuse. The square root of 5 divided by 3. When we find our adjacent value, we went negative. We went to the left. So we're going to put a negative there just to remind us. And this one here, we're going to have to use Pythagorean theorem. And it's a squared plus the square root of 5 squared equals 3 squared. A squared plus b squared equals c squared. Well, square rooting and squaring are inverse operations, so we get a squared plus 5 equals 9. 3 squared is 9. Subtract 5 from both sides. We get a squared equals 4. And then we're going to take the square root of both sides. We get a. There's 2. We can fill that value back into our triangle. Over here. When we look at the second triangle, cosine of beta, looks like a b there, equals 4 over 7. We are between 0 and pi over 2. Which is nice because we end up in the first quadrant and all of our functions are positive in the first quadrant. I'm going to put a b in here. And our hypotenuse is here. Sorry, I can't write very well slanted. My y, I know, doesn't look like a y. Across from the b is the opposite. And again, along the y-axis is going to be our adjacent side. Once again, we're given the cosine of beta is 4 over 7. Cosine is adjacent divided by the hypotenuse. So it's going to be 4 divided by 7. 4 sevenths. And we want to find our opposite. So it's going to be 4 squared plus b squared equals 7 squared. 4 squared is 16 plus b squared equals 49. And we can subtract 16 from both sides. We'll get b squared equals 33. And then when we take the square root of both sides, we're going to end up with b equals the square root 33. So luckily in our first 2 examples, we didn't have any radicals in there, but we've got one now. Square root of 33. So we followed our 2 steps. We've determined the quadrants, we've found the missing sides, now we want to use our formula, and it's cosine, and if you look at the top of your paper, you can see the cosine, and in this particular case, it's going to be the cosine of alpha times the cosine of beta, but because it's minus here, we're going to have to use the bottom sign. Minus is on the bottom in the original. So in the bottom is going to be a plus. And then it's sine of alpha and sine of beta is what we're going to be filling in. So let's go back over there and figure out what's the sine and the cosine. Well, based on our red triangle here, our sine of alpha is opposite divided by hypotenuse. So that was given to us even, I think. Oh, darn it. Darn it. Yeah, sine was given to us. The square root of 5 over 3. But we also need to know the cosine of alpha. And the cosine is the adjacent divided by the hypotenuse. So our adjacent length is going to be negative 2 over 3. When we look at our pinkish purplish triangle, our sine is going to be square root of 33 over 7, sine of beta, is opposite divided by the hypotenuse. And luckily enough, we were given the cosine of beta in our problem. We could still look at the triangle, but it's 4/7. That's a personal preference to me. I like to list what I know down here to fill this in. So now what we're going to do is we're going to finish this by filling it in. So the cosine of A is -2/3. And the cosine of B is 4/7. Cosine of beta. Sine of alpha is the square root of 5 over 3. And sine of beta is the square root of 33/7. We're going to 33 over 7. And then we're going to multiply. So definitely, again, with your fraction button, if you need to, we get -8 21st there when we multiply the tops together and the bottoms together. Over here, we can multiply the square root of 5 and we can with the square root of 33. And when we multiply those two together, we get the square root of 165 over 21. The only question is can we simplify 165? So if we check real quick, one value that I know 165 is divisible by is 5. And 33 is 3 times 11. So we've got 3 times 5 times 11. We don't have two of the same value to take out one. So we cannot simplify the square root of 165. So when we finish this problem, luckily enough, we already have common denominator. It's going to be -8 plus the square root of 165, all divided by 21.